Hi everybody, I'm Greg Fishel and welcome to bonus weather video numero uno for this week. And today we're going to talk about precipitation types and of course, and mainly winter precipitation types. So this is going to encompass snow, rain, sleet, freezing rain. And it's all about how temperatures vary in the atmosphere as you go up in height. And this is something you probably suspected already. So let's take a look now at case number one. And in this case, the entire column of air is below freezing except the lowest 1,000 feet. Okay, so here's the ground denoted in green. Here's our 1,000 foot above freezing layer near the ground, and then everything above that is below freezing. So in that region, we have snow falling. The snow falls into that rather shallow above freezing layer near the ground, but it's not thick enough to melt all the snow. Okay, so the snowflakes, a lot of them actually survive the trip all the way to the ground, and then they either partially melt as they're going through that above freezing layer, or they completely melt as they hit the warm ground, which is more than likely above freezing. And so complete melting occurs at that time. Now, a couple of things that are worth noting here in case number one. The melting process actually takes heat away from both the air and the ground. Okay, so here we're going from solid to liquid, and this is called the latent heat of melting. Okay, now the opposite direction is referred to as the latent heat of fusion. That's when you're going from solid to from liquid to solid, the freezing process, and that actually adds heat, okay? Same thing as the latent heat of condensation. When you have water vapor condensing into liquid, then you actually add heat to the atmosphere, whereas with evaporation, the other direction, you actually cool the atmosphere, okay? So it's the same thing, it's just going from different phases to different phases. And then if the snow becomes heavy enough, both the air and the ground may cool enough if you're borderline for that snow to start accumulating, okay? And so let's say you're 35 and all of a sudden it starts to come down really, really hard, then it could indeed cool the air to 32 or 33, and the ground temperature could cool to 32, and then you start getting that snow to actually accumulate on the road surface. So precipitation intensity is key in these borderline situations. Case number two. Two different layers below freezing, but they're separated from each other. They don't like each other, okay? There's the ground, there's the below freezing layer, there's the above freezing layer, and then below freezing again above that. So we've got snow there. Snow gets into the above freezing layer, and if it's thick enough, then all the snowflakes melt and turn into rain. And then those water droplets, if the below freezing layer is thick enough, then they refreeze into what we call sleet or ice pellets, okay? And by the way, that's the best I could come up with in terms of a symbol for an ice cube. Artistry has never been my strength, for sure. So the key here is this layer thick enough to melt all the snow, and is this layer deep enough or thick enough for it to refreeze, okay? Now, let's go on to case number three. We still have the two below freezing layers, but they vary in depth now a little bit. There's your ground, very shallow layer of below freezing air near the ground, and then above freezing above that, and then below freezing above that. So we've got our snow up there, and then that layer is plenty thick enough to melt everything into raindrops. And then that below freezing layer is so shallow that there isn't time for those raindrops to refreeze into ice pellets or sleet. And so it freezes on contact with the ground, and we're assuming the ground temperature is at or below freezing here, okay? So then you get freezing rain, okay, as opposed to sleet, and that's because that below freezing layer near the ground is just too shallow. There isn't enough time for those raindrops to refreeze, and so you end up getting just rain. It looks, if you're looking out your window, it just looks like it's raining until you walk outside and slip and fall on your sidewalk, and then you realize, there's something else going on here, isn't there? Okay, now, case number four and case number five are a lot simpler. The entire column is above freezing, and you get rain. Case number five, the entire column is below freezing, and you get snow, okay? Now, a couple of extra points here. Processes of evaporation and melting can have very important effects. If the above freezing layer is really, really shallow, or the temperatures within that layer are only slightly above freezing, the cooling from those two processes can be enough to change the precipitation type, okay? And I saw this happen this has to be at least 20 years ago, but I remember I was at home and it was raining, and it was raining in all directions. It was raining in Richmond, raining in Rocky Mount, raining in Fayetteville, raining in Charlotte and Greensboro, and so, where's the snow going to come from? And then all of a sudden we start getting reports in Southern Pines that they've got heavy snow and the temperature is about 4 or 5 degrees colder there than it is anywhere around it. It's like this island. And the whole thing was driven by the fact that the precipitation started to come down hard enough there that it cooled the air just enough so that now all of a sudden it's cold enough to snow. It's raining on all sides of it, okay? But in that particular area where the precipitation is coming down to beat the band, it cooled it enough to snow, and then as soon as the precipitation intensity let up, then it warmed up and went right back to rain, okay? So those kinds of things, can happen. All right, and finally, I want to take a look at this. These are two situations, and this is more or less the bottom of the atmosphere here, the ground, and we'll go up, maybe 5,000 feet, okay? So here's the freezing line. And we have two completely different temperature profiles here. Here, let's say it's, let's say it's 25 up here and 40 down here, okay? Now, the problem, let me go back. The problem here is that this area here that you see between the freezing line and the actual temperature line, then in order to get this entire area down to freezing, then the amount of energy required to do that is proportional to all of this area here, if I shaded all of this in, okay? And that's a pretty big area. Over here, this is what we call an isothermal temperature profile, where the temperature is constant with height, okay? So let's say the freezing the freezing line is here at 32, and let's say it's 33 or 34 from the surface all the way up. Now, the amount of energy required to cool that to 32 is just this little area right in here. And even though this is deeper than this layer, I think it's probably pretty fair to say that this entire area here takes up a lot less overall area than this thing here, okay? So in this type of a situation, precipitation intensity could definitely play a role in being able to cool this entire layer just a degree or two enough so that it would get down to freezing. So it's the same principle, and I think we talked about this one time, where in the morning, let's say it's sunny and you have a temperature of 25, but then you go up like a few hundred feet and the temperature is 40, okay? So the amount of area that you need to swipe out to get rid of that inversion is very, very teeny. So the temperature jumps real quickly in the morning, but then the rest of the day, the sun has to heat a 3,000 or 4,000 foot layer. For every degree the temperature goes up, it's got to heat that entire layer. And so that's why the rate of temperature increase goes down as you go into the late morning and afternoon. So these shadings of these areas give you an idea as to how much energy is required to do different things. All right. Hope that makes some sense. That is bonus weather video number 1 for today. We'll have another one for you Friday. The daily update is already posted, and we'll have another one of those coming up for you tomorrow afternoon. So you all take care, folks, and we'll talk to you soon. See ya.